The cloud makes you wait 400 milliseconds. Your phone's chip answers in 20 milliseconds. Same AI task, two very different homes. One a warehouse hundreds of miles away, one the silicon in your hand. Every AI feature you touch quietly picks one of two homes. A data center hundreds of miles away, or the silicon in your hand. That single choice decides how fast it feels, whether your data ever leaves, and what it costs to run. It's also why some features work in airplane mode, and why others just spin forever. Start with the far door cloud AI. Your request leaves the phone. It travels over the network to a data center. There it hits racks of specialized chips. The same graphics processors that render games, and Google's own custom AI chips. One enormous model reads your request. Then the answer travels all the way back. Here's the part people miss. That round trip is why cloud answers land near 400 milliseconds, before the model even thinks. Distance is physics. Your words hop router to router, city to city, and each hop costs time. But there's a real upside to shipping the work out. The data center has almost unlimited power and memory, so it can run models far too big for any phone. Models with hundreds of billions of internal settings, called parameters. Think of parameters as the knobs the model learned during training. More knobs, more nuance. A phone simply can't hold that many. The cloud can hold trillions. That's raw capability you cannot fit in a pocket. So the cloud is powerful, but it's also far away, which raises the obvious question. What if the AI never had to leave at all? Now the near door on device. The model runs on a chip built into the phone itself. A dedicated block just for AI math. Apple calls it the neural engine. Google calls it tensor. Qualcomm calls it hexagon. Same idea, three names. And here's the payoff. No network trip. The answer comes back in about 20 milliseconds. That's roughly 20 times faster to the first word. Even better, it works with zero signal. In airplane modes, on a planes, in a tunnel, it just answers. But nothing is free. There's a catch, and it's a big one. A phone has tiny memory and it gets hot fast. So the full data center model can't fit. Engineers have to shrink it. They round the model's internal numbers down to coarser values, so it takes less space. That's one trick. Then they train a small model to copy the big one's answers. That's the second. Both shrink the model without losing too much skill. The result still fits in your hand. But make no mistake, it is smaller and less capable than its cloud cousin. So the phone is instant. The cloud is smart. Which one actually protects you? That covers speed. Now the sharpest divide, privacy. Cloud AI has to upload your stuff. Your photo, your voice, your text. It all goes to someone else's servers to get processed. On-device AI does the opposite. Your raw data never leaves. Uploads zero. Think about the everyday features. Photos groups every face of your kid. No tagging, no upload. Your phone transcribes a voice memo as you speak it. The keyboard guesses your next word. On modern phones, all of that runs locally. None of it leaves. Here's why that matters more than it sounds. Every upload is a chance to be linked. A server can be breached. Data in transit can be intercepted. Data sitting on a company's servers can be logged, and it often is. Keep the data on the phone, and every one of those risks simply vanishes. There's no copy on a server to steal. That's the real meaning behind the zero uploads promise from the title. It isn't marketing. It's a direct result of where the work happens. If the data never lives, no third party ever sees it. But privacy is only one column on the scoreboard. What about the bills? Now the bill, and here the story flips. A single data center chip can pull hundreds of watts. That power costs money, and every question you ask runs up a tab. The phone runs its small model on a fraction of a watt. For you, that's free. So the pocket wins on cost, right? Not so fast. The phone pays a different way, in battery drain and heat. Ask it too much, it warms up and slows down. And it flat out cannot run the frontier models. For raw capability and massive scale, the cloud still wins. So we have a genuine split. Fast, private, cheap on one side. Powerful and huge on the other. So what do real products do? They cheat in the best way. They use both. The phone handles the small, fast, private jobs right there. The moment a task gets hard, long reasoning, a huge document, deep context, the phone quietly hands it off to the cloud. You feel one smooth assistant. Under the hood, two brains are trading work. That hybrid setup is why your assistant feels snappy on easy questions and still tackles the hard ones. But which brain gets the job? Here's the whole scoreboard in one look. Latency 400 milliseconds for the cloud, 20 milliseconds on the phone. Uploads many for the cloud, 0 on the phone. Capability, a giant model in the cloud, a shrunk one on the phone. Cost, paid per question in the cloud, free but battery fed on the phone. Now the mental model that ties it together. On device is for the fast, private, always on jobs. The ones that must answer instantly and must never leave your hand. Cloud is for the heavy thinking that simply can't fit in a pocket. And that combination, 20 milliseconds and 0 uploads, is the exact reason an on-device feature feels instant and feels safe. Instant because there's no round trip to wait on. Safe because there's nothing to upload and nothing to leak. That's the whole trick. The place the AI runs decides how it feels. This line is moving fast. The chips in phones keep getting stronger, and the models keep getting smaller. More of the cloud's job is sliding into your pocket every year. So the real question becomes, who decides? Next, we open up hybrid AI. Exactly how your phone chooses on the fly which half of the split each task belongs to.